For the given sets, universals 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then we're given sets A and B. First off, go find their union. So their union, remember, is going to be the merger of both sets. So we need to pick up A's 2, and then 4, 6, 8, 10, 12, 16, and 20. So we have to get everything from both sets combined together. Below that, we are doing their intersection. Their intersection is what they have in common. In this case, we're going to go through and look at it. What are in both sets A and in B? They both have a 4, they both have an 8, and that's it. So their intersection is smaller because it has to be what's in both sets. All right, B complement is everything in the universal not in B. So if I were to come up to the universal and just kind of take out B's 4 and 8 and 12 and 16 and 20, then from the universal that leaves 2, 6, 10, 14, and 18. So remember the complement is everything not in B, but still within my defined set, my universal set I'm working on. Next, we're going to do A intersection B complement. So that means I'm looking at my B complement set here, and I'm looking at my A set up above that I just highlighted in yellow. We are looking for what is in both sets. Well, both of those sets have a 2 and a 6 and a 10. So the intersection, what they both have in common. Next off, let's go look at shading a couple of Venn diagrams for the following shade A union B. So the union would be what's in, whoops, sorry about that, what's in both sets. So we're going to shade A and B. So the union is what's in both, A or B. Next, we're going to shade A intersection B complement. So if I were to come take A, we're looking kind of at what's going on in A here. We want to know where it overlaps with B complement. Now, B complement is everything outside of B. So what is outside of B and in A? So that would be this region here because that is in A and outside of B. Next up, we have an example here of a 100-student survey. 78 like pizza, 42 hamburgers, 28 like both. Use this information to go ahead and fill in the Venn diagram, and then we'll answer the question. So we have our pizza likers, and we have our hamburger likers. Whenever we set up a Venn diagram, we always want to get started here in the overlap. We have 28 that like both. Now within the hamburger circle, we can only add to 42. So 42 minus the 28 already listed in the hamburger circle leaves 14 that are going to like hamburgers but not pizza. And then of the 78 pizza likers, 78 minus 28 would leave 50. All right, so those 50 like pizza, but not hamburgers. Now, do all of our regions in the Venn diagram have a number to tell us how many are in it? Not yet. We're looking for the outside. There's got to be some that don't like pizza and don't like hamburgers. Well, how many do we have listed? We have 50, 28, and 14. So if we add what we do have together, that's going to give us 92 people. We had 100 surveyed, so when we take off, that leaves 8 people that don't like pizza and don't like hamburger. Let's go answer our questions. A, how many students like pizza but not hamburger? That means I'm looking for my quantity over here. These like pizza, but they don't want to be in the hamburger overlap. So that gives me 50 that like pizza but not hamburgers. How many students like only hamburgers? Well, that would be these 14 over here because they are in the hamburger circle, but they only like hamburgers, so no pizza. So that's 14. How many like neither pizza nor hamburgers? That's that set of 8 right on the outside that have nothing to do with the pizza or hamburger liking people. All right, so there's another example there to look at with Venn diagrams.